Today we're looking at section 11.8, surface area and volume of spheres. Our essential question, how can you find the surface area and volume of a sphere? So surface area of a sphere is 4 pi r squared, r being our radius. You notice this is very similar to our circle, which is pi r squared, because a sphere, even by definition, is basically a 3D circle. Circle, all the points on a plane, same distance from a point. Sphere is the same distance, points that are the same distance in space. So our formula is similar, 4 pi r squared. The volume of a sphere is 4/3 pi r cubed. So example 1, right? They ask us to find the surface area of a sphere. They give us a radius of 7. So I have 4 pi 7 squared, which gives me 196 pi, which is our exact answer. We're asked to estimate, multiply that out at 615.75 centimeters squared. Example 2 gives us the surface area of a sphere, right, 110.25 pi, and asks us to find the diameter. So when I set this up, we do 110.25 pi equals 4 pi r squared. Nice thing about this, I have pi in both of them, so my pi's just cancel out. Divide by the 4, at 27.56 equal to my radius squared. So I take the square root and I get 5.25 centimeters of feet to 5.25 feet. Okay, but then they asked me for the diameter, so I'm not done here. I need to double that. So 10.5 feet would be my diameter. Then volume, right, of our sphere in example 3, we have 3 millimeters as my radius. So I have 4/3 pi 3 cubed, which is going to be 36 pi. Again, that's my exact answer. If I multiply it out, I get 113.10 millimeters cubed. Something's a little weird with spheres. Because of our two formulas, we have the 4 pi r cubed or 4 pi r squared and 4/3 pi r cubed. Because I'm dividing by 3, when my radius in the volume formula, when my radius is 3, my surface area is actually going to look the same. The surface area would be 36 pi as well, but it would be millimeters squared. So it's not actually the same amount of stuff, right? Any radius smaller than 3, it's going to look like your surface area is greater than your volume. That's not actually true because the units here is cubed and the units in area is squared. Okay, but if you're dealing with a number less than 3 as your radius and you're looking for both, your answers may look weird to you, and that probably is why. And example 4. Example 4 asks us to find the radius of a sphere with a volume of 91.95. So 91.95 equals 4/3 pi r cubed. First, there's multiple things you could do here. First thing I would do is get rid of the 4/3. So I multiply by 3 and divide by 4. That gets me 68.96 equals pi r cubed. Divide by the pi, I get 21.95. Take the cubed root of that, which is 2.80 centimeters. Okay. And some of your calculators probably have a cubed root button. They may have a button that has an X in front of the cube where you could pick the number. Okay. And you would also raise it to the 1/3. Make sure you put that 1/3 in parentheses if you're doing that, though. Example 5 is probably our most complicated problem on here. Okay, I have some of it over here and some of it here. They asked me for two things. First, they asked me to find the surface area, and then they asked me to find the volume. I'm actually going to start with volume because it's more straightforward. Okay, your volume, I look here, I have half a sphere and I have a cone. So I do half the sphere plus the cone. So our sphere formula is 4/3 pi r cubed, and I multiply that by half. Our cone formula is 1/3 pi r squared h. So I plug in my radius of 4.9 into both of these. I plug in my height of 12.6. Okay, this is my volume of half a sphere, 246.40. This is my volume of the cone, 64.65. Add those together, I get 311.05 centimeters cubed. The surface area is more complicated for two reasons. One is the numbers they give me. The other is our formulas. Our formula for a sphere is half the sphere, because we have half the sphere. But our cone formula includes this circle here, which is not part of my surface area. So I need to take out that pi r squared in that formula. So your normal formula for a cone is pi r squared plus pi r L, L being our slant height. So I need to get rid of that pi r squared. Okay. If you're finding surface area of just a sphere, one of the things you need to think about, or just a half sphere, one of the things you need to think about is, do you have a bottom that you need to take into account? Because sometimes you'll need to add a pi r squared onto half the sphere. In this case, we don't need to do that because we have a cone on the bottom. The other issue is our L. They don't give me the slant height. So to find the slant height, we're going to do Pythagorean theorem. 4.9 and 12.6 are my A and my B. My hypotenuse is the slant height. So when I solve for my slant height, I get 13.5 centimeters. So then I'll be plugging that in for my slant height. So when I actually plug in here, I have 1/2 4 pi 4.9 squared, which is my radius, plus pi 4.9 my radius, times 13.5 my slant height. Okay. I multiply those together and left them in pi, add them together in pi, which is 114.15 pi. If I multiply that out, I get 358.61 centimeters squared. And so that's how I would find the surface area of that piece. Okay. And realize this is a composite shape here because you have two different things. And we'll look at a couple of those as we work down this sheet. Example 6, right, asks us to find the volume of the composite solid. So one, I'm only doing one thing here. Two, it's a little bit more straightforward. So I have a cylinder, right, which is pi r squared h, and I'm subtracting half the sphere. So 1/2 4/3 pi r cubed. Okay. So my radius for both of those is 3. My height for my cylinder is 5. So I plug those in. Pi 3 squared times 5 is 45 pi. 1/2 times 4/3 times pi times 3 cubed gives me 18 pi. And realize with multiplying those multiple fractions, there's multiple things you can do. You can multiply by 4/3 and then divide by 2. You could also do 1/2 times 4/3, which will be 4/6, and then reduce that, or not reduce it, depending on what you're more comfortable with. The key is that you use both of those and use them correctly. That'll get you the 18 pi. So 45 pi minus 18 pi is 27 pi. That is my exact answer. That would generally be acceptable. But if you want to multiply it out, you get 84.82 inches cubed. Example 7 Ask me for the surface area of a sphere. Oh no, it tells me the surface area of a sphere is 169 pi. They want me to find the radius. So 169 pi equals 4 pi r squared. Divide, the pi's cancel. Divide by 4, I get 42.25. Take the square root of that. 6.5 inches is my radius. Example 8, they give me the radius of a sphere. And then they ask me to find the volume of the sphere and round my answer to 2 decimal places. Okay. So I plug in 4/3 pi 2.4 cubed. I get 18.432 pi. Okay. But they asked me to round it to 2 decimal places, so I don't want to leave it in terms of pi. So I multiply that out and round. I get 57.91 centimeters cubed. And do watch what you're using for pi. If you use pi versus 3.14, that's going to get you a different answer. All right. So when you're looking at that and you're looking at rounding, it's important to know what you're using and generally be consistent in what you're doing, unless there's something that's telling you what specifically to do. So for example, here I use the pi button. That gives me 57.905, which would round to 57.91. If I used 3.14, because of the things that are after that 4 in my calculator, I get 57.876. So that would round to 57.88. Okay, so it does make a difference in your answer. So be consistent in what you're doing. If you have specific instructions, make sure you're following those. Example 9, find the volume of the composite solid. Round your answer to 2 decimal places. So here I have a cylinder and half a sphere. So I have pi r squared h for my cylinder, 1/2 4/3 pi r cubed for my half a sphere. All right, and since they told me to round the nearest 2 decimal places, I didn't even bother leaving pi in here. I get 1,479.56 plus 408.64. Add those together, 1,888.20 feet cubed.